Okay, sorry about that, got interrupted. But we're back to looking at this graph, right? And I'm trying to figure out what are these roots that I can't see. I know that my 2 that I found a second ago is right there, or right there. But I need to find these 2. Probably the best way to do that would be to go to the calc menu, 0, and then I want to move my cursor. I'm going for this one right now. So I need to make sure my cursor is like to the left of that root. And this one, I think, so see right now my cursor is way up there at the top. I can see it blinking. If I take one more step to the left, it's off my screen, but I know I can see down here like where it's actually located, and I know that it's past that point. So I'm going to go ahead and hit enter. And then I'm just going to move 1 back to the right so I know that I jumped past my root. Hit enter, and then enter 1 more time. And negative 0.6 repeating means one of my roots is at negative 2/3. Okay. And then I'm going to go do the same thing to find this root right here. So calc 0. So I'm watching and make sure I don't drop below the y-axis or below the x-axis, which I just did. So I'm going to come back here. I can't see it, but I know that I'm somewhere up here. I'm somewhere to the right. Okay, so enter, and then I'm going to drop down so that I'm below the x-axis. That's how I can tell by looking at my y's are negative. Enter, enter 1 more time, and I get x equals 0.5. So I know I have a root at 1/2. Okay, so that takes care of 3 roots. I know that I have 5 total. So what I'm going to need to do is divide these roots out of my original, okay, so that I can then say, you know, what's left over, and then find the roots of whatever's left over, probably using quadratic formula, okay? So a couple ways you could do this. You could turn each one of these into factors. You could say x minus 2, x plus 2/3, x minus 1/2. Multiply them all together, meaning FOIL, and then divide the whole thing by that giant ugliness. Or we could do synthetic division 3 times, once with each one of these numbers. That's what I'm going to go for. Okay, you could do it any way you want. Remember, synthetic division is all about the root itself. So I'm going to start with 2 into this guy. So 6, negative 11, 50, negative 95, negative 36, and 36. Drop this down. So that's a 6. 2 times 6 is 12. Negative 11 plus 12 is 1. 2 times 1 is 2. 50 plus 2 is 52. 2 times 52 is 104. Negative 95 plus 104 is 9. 2 times 9 is 18. Negative 36 plus 18 is negative 18. And then 2 times negative 18 is negative 36. And that makes a 0. And remember, that last one is always representing your remainder. So it's a good thing that that's a 0. Okay? And so this would now be the coefficients on my new polynomial. Okay, my new polynomial would now be 6x to the 4th plus 1x cubed and so on. So starting at x to the 4th. But instead of turning that into a new polynomial, I'm just going to use that as my new coefficient row, and I'm going to divide out negative 2/3. Okay, and I know fractions aren't our best friends, but it'll work. So now, drop my 6 down. Negative 2/3 times 6. Don't let this freak you out. This is negative 2 times 6, which is negative 12. Divided by 3 is negative 4. Okay, 1 plus negative 4 is negative 3. Negative 2/3 times 3, and if you're freaking out about the fractions, you could be using a calculator at this point, but I hope that you don't need to, is going to be positive 2. 52 plus 2 is 54. Okay, negative 2/3 times 54 is negative 36. It's okay if you didn't know that one off the top of your head. I did 54 divided by 3, which is 18. And then 18 times negative 2 is negative 36. 9 plus negative 36 is going to be negative 27. negative 2/3 of negative 27, kind of similar to what I did before. Negatives are going to cancel. And then 27 divided by 3 is 9. 2 times 9 is 18. Negative 18 plus 18 is 0. So this is my new remainder. Now I'm down to the point. So this was x to the 5th. This one would have been x to the 4th. Now I'm down to x cubed. Okay? And then I'm going to divide out one more. I'm going to divide out my 1/2. So drop my 6 down again. That poor 6 is just staying there. 1/2 times 6 is 3. Negative 3 plus 3 is 0. 1/2 times 0 is 0. 54 plus 0 is 54. 1/2 of 54 is 27. Negative 27 plus 27 is 0. And once again, that's my remainder. So this is where I'm at. And I should now be down to the point where I have x squared. So I now have 6x squared, really plus 0x plus 54. Okay? And so that's what's left over out of this giant polynomial after I take all 3 of these roots out of there. Okay? And it should be down to a quadratic because I started with a 5th power, divided once, that would be a 4th power, that would be a 3rd power, that would be a square. That would be a power of 2. Now, the fact that this is a 0 actually means I could get away here with not using the quadratic formula. But just because I think that you're probably used to doing the quadratic formula, that's how I'll do this one. So to get my other 2 roots, now I'm going to do quadratic formula on this thing. Okay, my A is 6, my B is 0, and my C is 54. Oh, 3i and negative 3i. Which actually means that this here should have been a yes. And now that I think about it, that was the one. Oh, I don't know if it's going to go back that far. Oh, I would have to retype it. That was the one when I plugged it all in, I got that number in scientific notation that was so tiny that may have just been a calculation error by the calculator. It may have actually been equal to 0 if I worked it out the long way. So yeah, that was a little bit weird. I'm going to change this to a yes. Okay. I didn't think about the fact that the answer I got was so teeny tiny. Sometimes your calculator, especially when it's giant like this, your calculator's off by just a little bit. There's a little rounding error. And so we had a number show up when it was actually so tiny and so close to being 0 that it really should have just been a 0. Okay? And quite honestly, you're probably going to be really upset with me now, but if we had said yes to that, we automatically would have had a negative 3i